Welcome to part 2 of CoreMotion. If you haven't watched part 1, go back and watch that one first. Just to quickly review, there's an accelerometer and a gyro and a magnetometer. The demo in part 1 focused on acceleration and the gyro. The implementation uses device motion. Now there's two approaches to the use of CoreMotion. There's periodic sampling, in other words polling. The application goes and gets data when it's required. The other is to set an interval, so data is reported on a periodic basis. Now a feature in Swift that's used for interval reporting is referred to as closures. Closures is a block of code with parameters. It's unnamed and it can be passed as an argument. So in other words, you're saying, do this with providing these parameters and this return value. To learn more about that, you should have this book. It's an iBook from Apple and it's free. After we do this quick code review, and if you're going to write your own CoreMotion code, you really should check out CM Motion Manager and CM Device Motion in the documentation window. Let's take a look at the code for the demo. Okay, the entire application is written in the view controller. There's no external classes or so on. The first thing you need to do is import CoreMotion. You have to create a CM Motion Manager, and you should only do one of these in your application. And because we're going to use interval reporting, in this particular case, I set a constant for the interval of 0.05, which is 50 milliseconds. That value is in seconds. I also create a property for the data that comes back, CM Device Motion, because it's used both for the acceleration calculation and for the rotation calculation. There's some user I/O stuff here. There's outlets. I'm not going to pay much attention to that. View did load is very simple. I make sure that the switch that controls the processing of gyro data is turned on when the application is first started. And I have a function called setup motion, and that's shown below here. And this is where the actual real action starts to happen. Now keep in mind, I don't test to see whether the iOS device has the capability of being asked for, and I also don't test whether it's actually currently being used. You can find out how to do that in the documentation. The first thing is set the interval, and then I set up for the updates. And two things are required here. One is, where do you want them queued? Now it actually, in this case, I'm asking to put them in the main queue. And the main queue is the one that handles the user interface. Now, under normal circumstances, you shouldn't bog that down, because what will happen is you'll get sluggishness in the user interface. However, in this particular application, it's fine. The other is an event handler, and this is where closures come in. So in other words, I'm saying when the interval is reported, perform this code, and with the parameters data and error. In other words, give me that information. There's no return value here. And the format of that is these parameter definition and the keyword in, and then some code, and then close with a bracket. Now, you really should take a look at closure syntax in the iBook. Two things happen here. One is the motion data, which is a property for the data, is actually loaded. Now before then, there's an if statement which tests to see whether the error equals null. Both the data and the error are optionals. So I check for the error, and I force unwrap the data. And then I call my function called motion update. And that starts doing the handling. If there is an error, all I simply do is I stop the interval reporting and send the string motion error to the console. Now, I've never seen that actually happen. Now, in motion update, I'm loading the text strings, and I'm always doing the acceleration data. So ACC update actually processes the data and returns a string which is displayed on the iPhone's screen of the acceleration data. Then I handle the label, acceleration label.txt. If the switch is turned on, because I can turn off the processing of gyro data, and I permanently do that to not create a distraction during the demo, then I go and process the gyro data. Okay, now the acceleration. What goes on there? Well, I'm returning a string because that's what's placed in the label. This is actually fairly simple. There's the X and Y and Z component that is extracted out of the motion data, but I take care of another problem here. I have a little helper function called no negative zero, because what ends up happening is that if you display something with a certain number of significant figures, there may actually be something greater or less than zero, or actually in this case less than zero, that isn't rounded off. All right. So what will happen is you'll get a display of minus 0.0, which I find relatively distracting. It's basically technically correct, but I do some functionality here where it actually gets rid of it. Then I create the string with a certain format. The gyro data is actually far more complicated because I'm doing an integration. All right. Now, that means I have to store past information. I get new information, I got to know the previous information. And I have a small structure here called helper. And all it does is record a X, Y, and Z initialized to 0.0. So 3 doubles. And I create 2 instances of that. One for storing the last reported information from the gyro, and the other is the last displayed degree information. Okay, also, well, I would place those the definition inside of the definition and the variables inside of the function. However, it's not possible to have static variables anymore inside a function like it was in C. So that they're defined outside of the function gyro update, which also returns a string which ends up getting displayed. Now, I do convert radians to degrees, and I set a conversion factor which is 180 degrees divided by pi is what that conversion is. I have 2 variables. I want to calculate the degree change, the degree change and the new degrees. In other words, how much change was there? This will become more obvious when I actually start going through the code. There's a nested support function which takes care of the fact that when you rotate, you may exceed 360 degrees. In other words, you can rotate to 2 times around the circle, so you get 360 times 2. What I want to display is only values within the 360 degree range. So what that does is it modifies the angle based on that concept. Now, here's the meat of the calculation. And that's why I had a little bit of trouble stumbling over the variables, because you actually haven't seen them used yet. Now at this point, we're really into the mathematics of numerical analysis, integration. It really doesn't have anything to do anymore with CoreMotion itself. So I'm going to quickly say that, for example, if I get the y component, I grab it out of the motion data. And what I want to do is I want to take that and I want to determine the change in degrees. So I want to take an average of the last value reported and the current value reported. Okay, by multiplying that by the motion interval, in other words, the time, what I'm doing is I'm calculating the area under that trapezoid, and I'm going to be summing them up. Now at this point, I also end up converting it to degrees. Okay. And now I want to store the last value because I'm going to need it again. And I want to update the degrees by taking the last degrees and adding the degree change. All right. So I'm updating the information that ends up actually getting displayed. Now I want to update the last degree. Now I want to take care of that cycle problem. Because let's say I'm going to pass 360, or I've just passed the 360 degree mark. Now the processing for the x, y, and z components are actually the same. I want to close by saying something about software versions. And we're done with the CoreMotion stuff, but at this point in time, it's November 2016. And what I'm using is Xcode 8. That's the latest one available. And to run that, iOS 10.10 or later. It's a Mac OS version. It's out currently. Has to be running to get Xcode 8. It's Swift 3. And I'm running on iOS 10. Okay, we're done. Have a good day.